So the question you have here says, assume you have the following data. Assume you have the following data. Let's see. Now, they gave us the experiments or the trials. This thing you see here, whenever you have this kind of box, it means concentration. Concentration of A, concentration of B. Now, for the first experiment, you have it to be 0.1. B is also 0.1, but the rate after everything, that is, the rate of this is not 0.01. Now, for this, you have this experiment to 0.2, and in B, you have 0.1. Concentration of B is 0.1. So, the rate is 0.04. So, the same thing with experiment 3. So, you have it there. Now, they tell us to get to determine the rate law of the equation. That's the rate law of the reaction, sorry, and then to find the rate constant. So, in order to do this, you've seen the question. This is the question. In order to do this, the principle that guides this is simply find out, looking at this, where, that is to determine for A. So to determine the rate law for A, to determine rate law for A, you have to keep B constant. So find out where B is constant. Looking at this question. So you can see that B is constant at 0.1 and 0.1. So at this 0.1 and 0.1, what are the values of A? It is 0.1, that is the first concentration of A is equal to 0.1. And the second concentration of A is 0.2. That is keeping B constant. Notice it, B is constant at 0.1 and 0.1. Now, to determine, we are coming to answer the question, but we cannot answer the question without knowing this. So to determine the rate law for B, we have to keep A constant. So find out where A is constant. And notice that looking at this question, A is constant at the first experiment and second experiment, because here you got 0.1. Then you did the experiment at this third part and still got 0.1. So A is constant at these three places. So now check again. That means that when A is constant, B is actually in this part where A is constant, and here you see that B in the first place, that is concentration of B in this place, is equal to 0.1. Then in this second place where A is constant, concentration of B, the second concentration of B is 0.2. So if I know this, and let's find out at those points in that of A, at A1, at the point where A was constant, that is checking out, keeping B constant is in the first two experiments. And the first one is 0.01, that is the rate, the initial rate. And in the second part, that is 0.04. Need to find it out. Now at the point where A is constant is in the first experiment and the third experiment. And in that third experiment, in the first experiment where A is constant is 0.01, and in the third part is 0.04. This thing is important, you note. Notice that A is constant here and here, while B is constant here and here. So when this is constant, you are able to determine A, while at the point where this is constant, you are able to determine B. So if I know that, if I've pulled all these things out, I will now apply the formula for rates. There's so much air here, so notice the paper flies out sometimes. So using the formula for rates, applying the formula for rates, the formula for rates is simply rates equals to concentration raised to power. So let's say M. And we can also say that rate is change, the rate of disappearance, let's say A here, with respect to time. But we have no business with this. So rate is equal to this. So whenever you are talking about rate of a particular concentration is equal to this. But now when you have more than one experiment, rate will now be given by, to find the rate law will now be given by rate 2, the second experiment, divided by the first, sorry, the rate 2 of the of the second experiment divided by the rate of the first experiment is equals to the concentration of the second experiment raised to power m divided by concentration of the first experiment still raised to power m, because everything about that particular concentration, let's say A here, is going to be raised to a particular power. So another way to put this is the same thing as saying root 2 over root 1 equals to so let's judge A now. We are using A first. So at the point where we judge A in the second experiment, so that is keeping B constant. We found out everything about keeping B constant. So if we are judging A using the values we have that we've pulled out, if you like, you take it slow and pay attention and remember and understand this. If you like, be having your own options. Pay attention, you understand it. So C, this is the second concentration. So at this point, I'll put it here, 0.2. This is the first concentration, first experiment, 0.1. So if I put the cent here, 0.2, 0.1. So all raised to power m. So because the particular concentration cannot have two powers, it's one power that it will have. It's either is zero order, first order, second order, third order. It can only be in any of the order. This power means order. So we are putting it in a particular order. Every concentration must have a particular order, and that order we don't know if that's what we want to find. Now the rate at the concentration 2, the rate at concentration 2 is 0.04. So this is supposed to be equals to this particular thing here is 0.04. This rate 2 is 0.04. Why? Look at it here. I already put it out. Because going back, why this one is going to be 0.01. So by the time you're doing uh 0.2 divided by 0.1, 0.2 divided by 0.1 will give you 2, and 0.04 divided by 0.01 will give you 4. Close to this. And remember that this one is raised to power m. So this is now going to be indices is set as 2 raised to power 2 equals to 2 raised to power m. Provided the bases are the same, the powers are equal. So m is equals to 2. So this m is equals to 2. Now to get for b, we've already pulled out everything for b, and we got b by saying find out where a is constant. So we found out where a is constant, then pulled out the values in those areas. So after pulling it out, we now have to get this law, which is the same law we have here, rate 2 over rate 1, and we already put it out. So the second rate is 0.04, so I will say 0.04 all over 0.01 is equals to 0.2 over 0.1 all raised to power n. This time around n. So I'm using n. I can't be using what I used for the other one because I don't know it. So I need to get that. So on 0.04 divided by 0.01 give me 4. Then 0.2 divided by 0.1 is also giving me 2. Wow. Okay. In this case, I will now have everything raised to power n. So this is going to be the same thing as saying 2 raised to power 2 equals to 2 raised to power n. So provided the bases are the same, n is equals to 2. So that means that this also 2. So that means that if I now want to write the rate law, if I want to give the rate law now, the rate law is given by concentration of A raised to power m, concentration of B raised to power n. So the rate law will now be equals to, Concentration of A raised to power 2, concentration of B raised to power 2. Remember that that's what rate is. So it's more like getting, since there are two, assuming it's one, it will be just this or just this. So since there are two, this is what you have. So, but a situation where they tell you to find the rate constant, you need to note, that rate is directly proportional to concentration. Let's say this is concentration A or concentration B. So if this is rate now will be equals to disappearance, meaning minus K into A minus K. The minus doesn't really hold any significance. It just shows that it is decreasing. You know that what rate of reaction means is the disappearance or the speed or how fast a reaction or a reactant forms a product. So if I know this, the reactant will be decreasing. So that rate shows minus. So if I know this, if I now put it here in order to uh, get K, in order to get K, I will go back to the given question. So if I go back to the given question, the first thing I see here, is what I'm using. So what I will simply do here is to say rates will be equals to minus K A and B, and notice that is raised to power 2, 2. Is it not true? Yes, it is. So this is now going to be, the rate I'll use is this one. So I'll have 0.01 equals to minus K into A. I got A to be the powers to be 2. So A will simply be at this point 0.1. At this point B, I'm using the first one, the first experiment. B is also 0.1 or raised to power 2, or raised to power 2. So by the time I do this, I will do 0.1 times 0.1 because that's what that means. So I have 0.001. So this is also 0.001. So minus K. I can say 0.01 times 0.01 is equals to 0.0001. So, and remember that it's times minus K. The K, this is the same thing as just K, but I'm putting minus to show you that it's 0.01. So making K subject of the formula, I'll divide both sides by 0.0001. So it's now going to be 0.01 divided by 0.0001. So I'm getting 100 equals to minus K. So I can say K is equals to 100, or I say K equals to minus 100. And I told you that this minus simply means disappearance. It doesn't mean minus like that. It is a negative value. It only shows disappearance. So now that you know this, thank you. Like and subscribe. Share. You have to pay attention. Things don't come easy. You have to take time, go through it, pay attention. Pay attention. Pay attention and subscribe. Be happy. Stop being proud. Be happy. Alright, thank you.